Now we're going to be treating Sous groups. But before I continue, I want to give a remark from the last lesson we had. If, for example, you're asked to prove a group commutative, prove that it's a group commutative, for example, or they ask you, is it a group commutative? If you prove commutative and then you find out that after proving it wasn't commutative, and then you prove associative and then the same thing happens, there's no need for you to continue proving element not or symmetric, because it's automatically not a group anymore. So it's easier, like if you see that you can you're proving a group commutative or a group abelian or a group non-commutative, it's best if you start with proving, after your lower the comparison, and then you prove the commutative, and then if you find out that it's not commutative, it's not associative, then c'est pas la peine de continue. There's no need for you to continue. You just conclude here that it is not a group commutative, or that it's not a group, that you associate it with the group you've been given, the set, with its loi, étoile plus multiplication, depending on what you've been given. So back to our lesson for today, dealing with Sous group. The interesting part about Sous group is that if you can prove that it's a Sous group, then it's also a group. Why? Because H, for example, we are picking H to be our Sous group, and then G is the main group. So H is a subset of G. This is G. H is a subset of G. So the same thing goes, like if I want to prove a Sous group, there are some properties that have to be verified before I can say it's a Sous group. What are these properties? First, I'm going to change my loi. Instead of using étoile now, let's use a triangle. The triangle is just a loi, but it's not like it's triangle, but we just call it a loi. So what do we have? Soit. Okay, let's do it this way. Cool. Soit G this is the loi now. Okay, so that's why I said it can be changed. They can change it for you in your TDs or your exams, your interros. So you should just be mindful, and the loi you're given is the loi you use. So soit G, the ça, en groupe. Okay, to prove the subset H contained in G, which is a group, the first thing you have to prove is that the element neutre appartient à H. That's the element neutre that you've already treated in the first part of your question about proving a group. That element neutre you find in group. So the element neutre of G should be in H. The second thing to prove is that for every X, Y in H, okay, X, loi Y should also be in H. The third thing to verify is the symmetric of X. So I will need only X. For every X in H, X minus 1 should also be in H. So if I can verify these three properties, then I can say it's a Sous group. Then there are two manners. This is the first one. La deuxième manière est que, which is actually the faster method. The first method is, the first thing you prove that, okay, so I'll say the second method is that if I can prove that H is not an empty set, an empty subset. That's like H should contain at least one element. We can also use the element not here to prove this, because if I can find an element not in H, it means that H is not an empty subset. So the first thing to prove is that H is different from is not an empty DC. So we say H différent du vide. That's how we note it. Then the second thing to prove is that for every x, y in H, x, our loi, and the symmetric of y is also in H. So if I can prove this two, then like if I can prove these two methods, then I can say it's a Sous group. Or if you can't go with these two, you can pick these three and then say it's a Sous group. So like I said at the beginning, that a Sous group is also a group. They share the same loi de composition. That the Sous group H shares the same loi de composition with G. So it can also be called a group. So that's the whole idea about Sous group. In our next video, we'll be going more into the same chapitre group. See you in the next video.